Okay. Chapter 19. The next couple chapters we're going to get through today, this one's dealing, starting with the phylum Arthropoda. And we're going to look at several classes. In fact, the next three chapters really fit this. And we'll finish on some crabs and crayfish and crustaceans today. And that'll leave insects to start up with next week. But this one, phylum Arthropoda, of all the phylums that we'll study, this is the largest. Okay? This is the largest phylum of any animals that we'll study. Now, the largest class is Insecta, the insects. And I believe fish comes in a pretty close second when we start looking at those a little bit later. There's huge numbers of these. But one of the first things we're going to look at here under phylum Arthropoda is why there's so stinking many of them. And could we do without them? And that's some of the first issues they talk about. And then we'll break down and talk about some of these disease-carrying little organisms and what they do. They tell you at the beginning of the chapter, I'm starting on page 406, phylum Arthropoda is currently the most species-diverse phylum of the animal kingdom. Composed of more than 3/4 of all known species, approximately 1,100,000 of arthropods are recorded, and they think there's many more to be found. That's amazing, isn't it? So it's including spiders and scorpions and ticks and mites and crustaceans and millipedes and centipedes and insects, which basically the next three chapters we're going to be looking at. Now the size of these, few exceed 60 centimeters. Most of them are very, very small. Then you get into the Japanese crab. The Japanese crab could be as big as 7 feet wingspan on him. That's a big crab. So arthropods are usually active, energetic animals. They can be carnivorous, they can be herbivorous, or they can be omnivorous. They're not picky. And really what makes them fit that is as they go through metamorphic stages, they don't ever compete against one another. And without competition, they thrive more. And so they may hit a stage where they're herbivorous and then may become omnivorous as an adult or vice versa. Who knows? What are they good for? Could we do without them? Technically, across the board, we really can't. I mean, we look at all these bad insects and these spiders that causes heart attacks and strokes and everything else that are actually harmless to us. But here we are this big, and there they are that big, and they're scaring us to death. Come on. It's just a spider, right? A good spider is a dead spider, I know. So I've heard that 100,000 times along with the snakes. When we get to the snake chapter, you'll say the same thing. Most snakes are not harmful. Unless you live in Australia, when 90% of the snakes over there can kill you. So be careful moving to Australia. Yeah, they're all harmful over there, and they'll hunt you down. So they tell you that they, for humans, they compete with us for food. They spread serious vertebrate diseases. They're essential for pollination. If we don't have that, we might just starve to death. So that's the main importance. And they serve as food in the ecosystem. They can yield drugs, generate products such as silk, honey, beeswax, and dyes. So the question the book poses, are they important to us? They're important to us for the good things, and they're important to us for the devastation they occur too, isn't it? So yes, we have to have them. Now they list, starting on page 407 and 408, why there's so many of them. The first thing they list is a versatile exoskeleton. An exoskeleton has to be shed to grow to the next metamorphic stage. And some of these arthropods go through metamorphosis. In fact, a lot of them do. And some just are not necessarily metamorphic stages, but they go through growth stages. And even as adults, they'll shed their old skeleton from time to time and grow a new one. You ever catch a soft-shelled crayfish? Well, it was in the process of growing, hardening its new one because it shed its old one. That's all it come down to. So the versatile exoskeleton is extremely tough. It is a polysaccharide cotton with some protein coatings on it. So it's really, you think that shouldn't be that tough, but it is. It can actually withstand boiling alkali. If you threw it in there and boiled it, it can hold up to it. It's pretty tough. And it's light, and it's versatile. Serves their purpose really well, if you think about it. So that's number one. Number two, Well, before we move on, they talk about when they do shed this, and they'll mention this in 2 or 3 different places in this chapter and the next one, and possibly even the next one. The process of molting is called ecdysis, and that is on page 408. The process of molting is called ecdysis, and the hormone for molting is called ecdysone. Ecdysone. That's in bold print at the bottom of 408, ecdysis and the molting hormone. We'll see in the next chapter that there's X and Y organs involved with crustaceans. One produces a molt inhibiting hormone when they don't need to molt, and the other produces the molting hormone when they're ready to molt. So, number 2, why there's so many arthropods. Segmentation and appendages provide for more efficient locomotion. That's pretty self-explanatory. We're dealing with either 6 to 8 legs, and if we're talking about insects, 96% of all insects can even fly. So that's some serious appendages. They can cover some territory in a hurry. So I think that's pretty self-explanatory. Number 3, air pipe directly to cells. Maybe one of the most overlooked things that they have here. This is called the tracheal system. And not all arthropods have this, but the tracheal system is for a lot of terrestrial arthropods, and it's a direct airflow system. Have you ever observed a grasshopper on your windshield before you hammered it with your windshield wipers? And you watch his abdomen swell and shrink? Have you ever noticed that? If you haven't, you need to. Because there's a reason why his abdomen, he's not getting pumped up to attack you through the windshield. That's not what he's doing. When the abdomen swells up, it reduces air pressure inside the abdomen, and there's little spherical holes along each side of the abdomen, and air rushes directly into the tissues. When the abdomen shrinks back down, it forces the air back out. So it's all it is, it's a direct airflow. It is the most efficient terrestrial respiratory system that we know of. It is extremely efficient. It's not like us. We suck air in, goes to the lungs, goes to the capillaries of the lungs, in the alveoli, exchanges in the blood, then blood takes it to the tissue where it exchanges across a couple different cell membranes to get to where it's going, and finally it's where it needs to be. That's not a really efficient way, but yet it works quite well for us. Okay? So air pipe directly to cells. Tracheal system you'll find on some spiders, most all insects. Some spiders have book lungs. Some of the crustaceans, obviously being aquatic, will have gills. So there is some variation, but a lot of them have this. Number 4, highly developed sensory organs. You think, well, that grasshopper wasn't very smart when I stomped him with that big boot. Well, if you ever missed him, the second time would be much more difficult. They're pretty quick learners. Now, do they have a large brain to work with to start with? No, but they learn pretty quick. So there is a sensory system that does work pretty well. And part of that sensory system is their compound eyes. Now, spiders have 8 simple eyes, but a lot of the insects and other arthropods have compound eyes. You ever walked into a department store, and this wall's lined with TVs? It's almost like back of Walmart back there, except if you walk into a room and 2 walls in the backs, all TVs, all turn on the same channel. You ever seen that or similar to it? That's what they see. It's almost like, all right, I know he's there, just where's he at exactly? Which one's the real TV kind of deal? But now, could they pick up movement with that kind of eye? That's what they base it off of, is picking up movement and heading in the opposite direction of that movement. That's what they're surviving off of. Number 5, complex behavior patterns. More complex than we would think. They exceed most other invertebrates in complexity and organization of their activities. Innate or unlearned behavior unquestionably controls much of what they do. Well, instinctive behavior, eat, sleep, drink, reproduce, that kind of thing. It's the same thing with most all animals. And number 6 is maybe should be number 1, really. The limited intraspecific competition through metamorphosis. Now, not all arthropods go through metamorphosis, but when you get in, especially to the insects, you have a lot of metamorphosis. They'll go through several instar stages, and each stage will eat a different food. It doesn't compete with the parents, and finally they reach adulthood, and now they're reproducing, and all their offspring is not competing with them, and so there's just huge numbers of them. And metamorphosis is it, number 6. From there, we're going to be looking at subphylum Chelocerata, and the class is on page 412, class Arachnida. Everybody's favorite little class here. Who absolutely is deathly afraid of spiders? Darren.
Bunch of holes in the wall. don't mind.
Well, I stepped on a fiddleback last night with my bare foot on purpose to kill it. It's got to turn up and bite, so I got him going down. But, you know, we've got those everywhere in our houses, so we live with them all the time. Spiders, most spiders are harmless to humans against popular belief. We create our own demise by our fear of them. And by saying that, it's probably the increased blood pressure, the strokes, the heart attacks that comes with the seeing of a spider in the house. What's he doing there? This time of year, he's chasing the little insects you don't see in the house. That's what he's doing. He's doing you a favor. You ought to pick him up and pet him and say, "Thank you, little buddy," and turn him loose. But instead, we get this monster shoe or fly swat and go, "Hawa!" and kill the poor little fella. Yeah, the zoology books work really well, don't they? So I've lost a lot of hearing in my life raising girls in the house because they see a spider and they're right there, and instead of saying, "Dad, there's a spider," they, "Ah, bloody murder." I mean, it's just like somebody's killing them or hanging them, you know. Well, what'd you say again? I'm cleaning my ear out, and I swear I've lost a lot of hearing because of it. And I found them standing on the toilet. It's like, "What are you standing on the toilet for?" "There's a spider." "Well, get in there and kill it." I make them kill their own spiders if they're going to kill one, but usually I just kind of shoo them on out of the house or get them out of sight, out of mind kind of thing. So get up underneath the cabinet, you don't bother anything. Now the ones I will kill will be the brown recluses and black widows. Those are the ones that are harmful to us. And you need to be able to identify those. Of course, my wife, everything's a brown recluse and a black widow. If it's black, it's a black widow. If it's brown, it's a brown recluse. I don't care if it's this big or this big, it's going to be dead. And she asked me after she kills them what kind they are. Of course, there's some mutilated. You can't really tell, but I'll tell her they're all wolf spiders. Everything's a wolf spider. Wolf spiders are just hunting spiders, and they're very good insectivores. And there's several field spiders that sneak in the house. Those are pretty good size. They sneak in the house this time of year. Again, not going to cause any problems. They're in there taking care of little insects that's trying to get in and out of the cold too. So they're our allies. Too bad they're not. They should negotiate more, shouldn't they? Well, spiders have 8 pair of legs, of course. They have a pair of appendages called chelicerae that terminate into what's referred to as fangs. And then they have the first pair of legs, which almost are hands for them, called pedipalps. And I have a couple test questions about chelicerae as fangs and the pedipalps, because those are kind of pretty important little aspects to a lot of spiders. You know, we know the story and the history of the black widow. She mates with her lover and kills him and eats him. I mean, that's where the name come from. There's a lot of species that actually do that. You seeing some tarantulas crossing the road recently? Y'all been seeing a few? I've seen a couple.
Yeah, we were shooting in the gym and running ran across the 3-point line.
Should have passed it to him. I'm surprised y'all didn't. It's that. Well, tarantulas are none different. The purpose of the male tarantula is to mate with a female. That is his one and only goal in life, knowing he will not live beyond that. Now, what a goal in life. Here you have a male tarantula out, they're probably ones we're seeing out cruising, trying to find that female. And once he finds that female, he has to negotiate a little. He has to sweet talk her a little. I guess you can say put her in the mood. And at the same time, he has to place sperm packets on his pedipalps, his little hands. And he has to know exactly where to place those. Well, I'm sure he's caressing her with the other pedipalp. If for some reason he makes the wrong move, she'll just kill him and eat him right there. And this poor fella, he's obviously a virgin male because they're dead after they reproduce, so how much experience has he had? He doesn't really have a lot of hope, does he? So if she's a little on edge, bad day, a little moody, you might as well just give it up and say, just kill me and eat me. But I guess some of them get the job done because there's still little tarantulas running around out there. But they will eat them, and if they don't like what they're doing to start with, they'll eat them prior. So depends on how hungry they are. Well, I hadn't eaten but 2 today. I think I'll eat this little male. He's just a snack. Probably the case. All spiders are predaceous, feeding largely on insects, which they effectively dispatch with venom from their fangs. Now that venom is not necessarily poisonous to us. Like I said, there's only 2 genera that's poisonous to us. Don't shake your head no over here. I should have brought a whole bottle of spiders and turned them loose in here and made y'all sit through class while watching spiders run through the room. I did see a centipede yesterday. I felt sorry for him, or I brought him in. He was about that long. The kids are like bird dogs. Dad. They had him pinpointed, and I said, yeah, I caught one a couple years ago, but it wasn't this big. This is the biggest one I've ever seen in my life. But then they had to go get Mom. Mom! They had him on point. It was a monster centipede, though. But we left him alone, because he's just gonna go eat some insects. He's not gonna bother us. What would y'all have done? Kill him. It's just all about death with y'all, isn't it? All about death. Hopefully, one thing you'll learn out of this class is what to kill and what not to kill. You gotta weigh your odds in there sometimes. Your odds are a lot better when you have a big book or a fly swatter in your hand, isn't it? Spiders breathe by means of book lungs or trachea or both. Okay, book lungs is pretty common for spiders. Their excretory system is Malpighian tubules. It's probably one of the simplest systems out there. It's about as simple as that little nephridia that we saw in some of the worms earlier. 8 simple eyes. Your study guide may actually say spiders have 8 compound eyes. Well, that's false. They have 8 simple eyes. Okay. And then we get into web spinning habits. Now, not all spiders spin webs. This time of year, we see a lot of webs out there. But not all spiders spin webs. There's some that hunt their prey, and that a lot of your field spiders, wolf spiders, they're hunting their prey. There's jumping spiders, and some of these spiders have such poor eyesight, they have to be like within centimeters of their prey before they ever know, oh, there's something I can eat. But I guess it works. But these web spinning spiders are pretty unique. Here they've tested the strength of some of these webs. The scleroprotein secretion emitted as a liquid from the spinnerets hardens to form a silk thread. Threads of spider silk are stronger than steel threads of the same diameter, and second only to fused quartz. That's some pretty serious. There's even one species of spider in Australia, over there with all those poisonous snakes, that spins a web that we have taken and spun it even tighter and made bulletproof vest out of it that's lighter and stronger than Kevlar. If we could just get us a company to raise these spiders and spin these webs, we could sell some bulletproof vests. They actually are lighter. They're, of course, less heavier on the military, whoever's wearing them. It's really an ideal situation. If we just can't gig these spiders to produce more, hurry up, produce some more, you know. We need to raise more spiders, I guess. So what'd y'all do? Y'all probably killed the spider. So there's some of your web spinning habits. They list, there's fisher spiders. See, there's wolf spiders. I didn't just make that up. Jumping spiders that simply chase and catch their prey. Reproduction, here's where they talk about a little courtship ritual, precedes mating. Before mating, a male spins a small web, and that's, of course, if they're a web spinning spider. Deposits a drop of sperm on it, and then picks up the sperm to be stored in the special cavities of his pedipalps. That's where he's going to place it. So it's kind of the same situation I mentioned earlier. Then, if she does get fertilized, she'll put her eggs in a cocoon. We see a lot of those hanging around in spider webs now, where actually the spider may be gone. Have you seen those? The spider at the top of the left-hand page is a real common spider around here. Most of y'all would absolutely kill it in a heartbeat. This is a lot. I hear people call it a banana spider because it's so yellow and it's pretty long. But this is a garden. It's a simple garden spider, and it is an insect mutilating, killing machine. It's absolutely harmless to us, unless of course you walk into the web and it crawls on you and gives you the heebie-jeebies, and then after 4 karate chops, you've taken it out. But you see a lot of these. Notice here in this web, a grasshopper has gotten in the web. He's going to spin it up a little more here. And then he's going to take his chelicerae, which end as fangs, and he's going to stab them in this grasshopper and he's gonna insert a digestible enzyme. It's gonna basically make soup out of the inside of this grasshopper. He'll give it time to digest, come back a little later, stick its chelicerae back in there, and now use them kind of like straws, and go and suck up all the goodie from the inside. Now, some spiders that spin webs have cutting mandibles, and they'll go ahead and eat the exoskeleton. They'll eat it all. And some will leave the skeleton hanging in the web as a decoy. So the next grasshopper comes by, oh look, there's old Fred sitting up there, let's go see what Fred's up to. So they jump up there and they get hung up in the web, and we use decoys all the time, don't we? Spiders aren't stupid. They get Fred's buddies in there, and he's got a big meal ahead of him, right? And then there's a fisher spider, and of course a trench at the top, and then these two right here, the black widow and the brown recluse. What's another name for the brown recluse? Fiddleback. Heard the term fiddleback? In your house, you have brown recluse. You may not see a lot of them, but they're there. And there's plenty of them. Because they're recluse, they don't typically come out when you're messing around. A lot of noise, things. But if you like to store things, if you like to store boxes, your closet's just a little cluttery, those brown recluses love you. In fact, they'll probably kiss you for it one of these days. No telling how many cross you while you're sleeping at night. Yes, ma'am?
I'm going to get me an Indian taco for lunch. You want one?
Sure. I'm on film, so I gotta keep moving
Oh,
here.
I'm sorry. Okay. Everything on it?
Yeah.
Onions?
No onions.
No onions?
No.
Okay. All right.
All right, thanks. So, the brown recluse is everywhere. You're not gonna get away from them. They're in your house. They love you to stack your clothes over in a corner. You ever wear a pair of pants, say, well, they're not dirty, I'll wear them again tomorrow. Instead of hanging them up, you just throw them over in the corner, or in some cases, you stand them in the corner. You have husbands like that and sons like that? Yes? Well, brown recluses love to crawl up in there, so when they put their leg in them this time, it feels like maybe pulled a hair on their leg. But it wasn't. It was a brown recluse bite. It's like, get out of my territory, your leg's taking up my space. So, do they cause deaths? Are they really, really dangerous? They cause very few deaths. Now, will they rot your flesh out and make you stink? Yes. Their toxin is a hemotoxin that actually will start with a little hole rotting out and end up with a crater rotted out of your leg. And it's more dangerous for the elderly. Somebody your age would probably maybe not even lose rotted flesh. If it's bad enough, you would, but you'd probably survive. May not even know you had a spider bite. You may think it was just a bull or an infected hair or bad pimple or something that we get from time to time. But the elderly will think the same thing. They'll, well, I'll get over it like I did when I was 10. And the problem is half their legs rotted out now, and the doctor has to scrape all the rest of the rotten flesh out. Then we have to treat an antibiotic for bacterial infection that it's created. And then when it finally heals, we have this huge crater, if it heals. What if they are diabetic and they have this problem? Well, you think healing, that'd be a slow process, wouldn't it? So it's not something to take lightly. If you know for sure, or you're really suspicious it's a spider bite, getting a doctor to treat it up front would reduce your chances of other further problems. The black widow produces a neurotoxin. Not many deaths. In fact, I think they tell you, where's it at? Not many deaths. Where's it at?
That's 4 to 5 out of every 1,000.
There you go. I knew it was in there somewhere. 4 to 5 out of every 1,000 reported. Of course, those that were dead already couldn't report it. You wonder how many of those there are, but not many. And has anybody ever been bit by any of these two spiders that you know of? See, and I'm telling you right now, they're in your house and they're everywhere around you. You live among them, or they live among you, however you want to put that. And see, lived this long already in your life and not been bitten, and that's not an uncommon thing. So if you get bit once in your life, it's probably a rarity. But black widows producing the neurotoxin affects you a little bit different. Starts out looking the same, but can spread and attack some nerves. Not many deaths. My son got bit several years ago. The black widow was in his shoe. Now, why a black widow would crawl in a boy teenager's shoe, they must have no smell whatsoever to them, because if they got in that shoe and took one whiff, he should have been dead in that shoe. You know what I'm saying? But the spider bit him, maybe in self-defense for stinking up the shoe, I don't know. Bit him right on top of the big toe. Oh, and my wife had him in his deathbed. We was gonna have to drag him to the emergency room, stick IVs in him. He was almost dead before he got his foot out of the shoe. And I said, it's just a spider. Oh, but it's a black widow. You know, she's killing the shoe. I'm surprised she didn't set the shoe on fire just to kill the black widow again. So I said, let's just watch him. If he has difficulty breathing later, we'll haul him to the emergency room and save him at the last minute. And all his toe did, father speaking, mother speaking, right? I'm paying the bills, so I'm waiting till the last minute. So all his toe did was start sweating. It just started sweating profusely. I mean, it never got past his big toe. His big toe just started sweating. And I asked him, I said, how you doing? Oh, I feel fine. Toe looked kind of bad, but you know, lose a toe, you're still alive, right? So worst case scenario, we just chop the toe off and we're still good. It never bothered him respiratorily or anything. I mean, without looking at it, we'd never known, but that was the case. And the spider, as soon as he bit him on the toe, I'm sure died because it bit him. He got killed, I'm sure. All right, so there's your brown recluse and black widow. Moving on from there, we'd look at scorpions. And anybody ever been stung by a scorpion? You knew that, didn't you? They put a whooping on you. You been stung by a scorpion? Huh? Yeah, now, scorpions, again, humans are not technically allergic to scorpions. Their stings typically causes very little swelling, but boy, when they sting you, you know it. It's worse than any bee sting, wasp sting, they pop it to you. And that in itself is enough to kill them, and I don't blame you for that. If they're gonna sting you, if they leave you alone, they're really good insectivores. I know you don't want them crawling around the house. So I can't argue with you a whole lot on them, because if they do sting, it's really bad. Now, our scorpions are not poisonous. There are some out there, and I think there's some in Mexico, maybe some in Australia. And they typically say in here that the smaller the scorpion, they're actually more poisonous. The larger scorpions use their strength to catch their prey, but the small ones are the poisonous ones. And some of these real poisonous ones in Australia and Mexico, if you don't have an anti-venom there, they'll kill you. That's how poisonous they are. We don't have those in Oklahoma. Now, if you want to move to Mexico, good luck with that. Don't drink the water either. One of them two is going to get you. But these scorpions around here are insectivores, and we have plenty of them around here. And one thing, in fact, we watched a YouTube video one time. You can probably go out there and they'll put something in there to fight a scorpion. You can pull up scorpion fights or something on you, and there's some really neat fights out there they're fighting. But if you really have good self-control, and that scorpion stings you, boy, it makes you mad. You just want to take fly swatter and obliterate him, but capture him alive. That's what you need to do. Take him outside, build you a little ring of fire, and then drop him in it. And then when he decides he cannot escape this ring of fire, he'll start stinging himself to death. And when he starts stinging himself, that's when you get yourself some of that. You just get yourself some more of that. Add a little fire to it, heat it up a little bit, and cheer him on, and he'll kill himself. Commit suicide when he cannot escape. That's a cruel way. Well, that's what I did in my childhood, but that's a cruel way to handle scorpions. Now you know why I'm this crazy mad scientist up here telling y'all stories. I can't believe I put that on film. That's all right. They also tell you over here that scorpions are truly viviparous. Now, of course, they erase my board all the time. There's 3 reproductive terms we need to look at. There is oviparous. There is viviparous. And the one in the middle actually is ovoviviparous. Now, we're going to see these terms a lot, so let's get used to them. Let's get an understanding of what's going on. There's some species of animals that'll fit all 3. We are this one, we're viviparous. Humans are viviparous. The further up the food chain we go, you'll find more viviparous situations. Oviparous, it means egg birth, okay? So an animal that's oviparous can have internal or external fertilization and will produce an egg. Would a chicken fit that? That's internal fertilization, production of an egg. What about a frog? External fertilization produces an egg. There's some snakes that fit that. There's a snake for every category, by the way. But there's your examples. Ovoviviparous. The literal meaning is live birth, but may not have a placental attachment. Must have internal fertilization though. And this is really weird because this is kind of the weirdest category. There's snakes that fit this category, but probably one of the common examples used in books is aquarium fish called mollies or guppies give live birth. And there's some other fish as well that does that, and there's other animals, but there's a snake that fits this, and there's actually a shark that fits this. So this is kind of the odd duck of the reproductive modes. And then viviparous must be internal fertilization. The literal meaning is live birth again, but placental attachment. That's us. We have a placental attachment. And so we fit this, and all animals that we we're probably most familiar with pretty much fit this. There's always exceptions to the rule, but in general, this explains these. All right, from that, let's move over to 416 and look at daddy long legs, everybody's favorite spider. How many of y'all think this is the most poisonous spider on earth? That is a farce. That's a myth. It is wrong. This spider's mouth is so small it couldn't bite you if it wanted to. It is a scavenger. It eats detritus material. If it was poisonous, it would have poison to kill something with. It's eating something already dead. And it has odoriferous glands. You ever messed with one? They stink. And it also has the unique ability of growing its legs back, because what are you going to grab if you're trying to catch it? Legs. So it shucks a leg and keeps going on the other 7. You grab another leg, shucks it, it's still got 6. It has hope as long as it has a leg. And it'll grow it back. So there's a scientific experiment for your kids when they get to school as they're growing up. Pluck all the legs, put it on some detritus material, see how long it takes to grow the legs back. Of course, it's going to stink, but it's keeping the kids right. Then let's look at ticks and mites. You know, ticks are probably second as what we would call important vectors for bad diseases. What do you think would be the first number 1 vector to carry diseases? Mosquito. Can we be more precise? Female mosquito, thank you very much. There's something to be learned from that. That's the reason I have to emphasize that material. Ticks carry enormous amounts of diseases. I mean, of course we know there's different sizes of ticks, and there's varieties of genuses of ticks and species of ticks, and we're going to talk about some of them as we go, but in this same category, we're going to see mites as well. And you know, there's a mite that's on us as we speak. It's prevalent in the majority of humans. Harmless. It's not causing any problems whatsoever, except you'll start scratching more now that I'm telling you this. And it is a close cousin to the Demodex mite, which causes mange in dogs. So you're this close from being mangy. Isn't that nice to know? Yep, it's all there. And then there's other mites called spider mites that they destroy plants. They create little spider webs on the back of leaves of plants, and they suck the juices right out of plants. And you know, they create all kinds of agricultural problems as well. And there's quite a few of those. And then, of course, your favorite little mite would be a chigger. Has anybody never got a chigger on them? I believe I had somebody in class yesterday said they'd never had a chigger on them. I said, well, you've not lived yet. Chiggers, you don't know what a chigger is?
I don't really. If I saw one, I would be like,
You probably didn't see it because it's so microscopic. And the best way to get rid of them is try to suffocate them somehow. And they say fingernail polish, well, you'd be there all day trying to get all those little spots, right? So what is it, calamine lotion that they recommend, and it coats them pretty good. And you can grease yourself down, whatever it takes to suffocate them, that's what'll get rid of them the fastest. But chiggers have the uncanny ability of finding your most vulnerable places, and that's where they want to land. Have you noticed that? Yeah. They know right where to go to irritate you the most. I said, I think your last nerve is right here, and that's where they land. And not just one, there'll be 20 land right there. Just eat her up. So, chiggers, there they are. They feed on dermal tissue of terrestrial vertebrates, including humans, and may cause irritating dermatitis. Imagine that. Irritating? Yeah. All right, let's get into the ticks. Ticks are among the world's premier disease vectors, ranking second to only mosquitoes. Second to mosquitoes. They surpass other arthropods in carrying the great variety of infectious agents, including apicomplexans. That actually causes Rocky Mountain spotted fever. You've heard of that? You've had it. Rickettsial, viral, bacterial, and fungal organisms. So between all of those, you get anything from, and there's different variations of bacteria, but basically all causing the same thing, whether it be tularemia, which is rabbit fever, Rocky Mountain spotted fever, Lyme's disease. Those are all tick-borne illnesses that we have right here in Oklahoma that is poorly diagnosed because we don't have that many cases. We're getting more and more cases, but we have not that many compared to some other parts of the nation. They can tell you the reason why they call it Lyme's disease. They thought it was something in the water, but in Lymes, Connecticut is where they first identified Lyme's disease, and yeah, they had this outbreak of tick-borne illness in the city of Lymes, Connecticut. So that's where they originated the term. They're hard to diagnose to an extent. A lot of times the telltale symptoms are not there, and so the doctor just, it's kind of like rolling the dice. This is a good chance what it is, so this is the way we're going to treat it. And a lot of times they hit it right. But we have a lot of doctors just ignore the fact that it can actually be here. And you had Rocky Mountain spotted fever. Did you get diagnosed early enough to treat it?
But I had the target, so that's how they knew.
Well, there was, my dad had a case of Rocky Mountain spotted fever. It did not have classical signs, and it was misdiagnosed 4 times before he was treated properly. Never diagnosed with it, but they actually, after he was finally just put in the hospital because it had gotten so bad, the respiratory therapist, because it actually had reached his lungs at this point and his oxygen content went out of the 90s into the upper 80s. He comes in and asking questions about, you ever out in the woods? Do you live on a farm? And these are all no-brainers for us. But they'd run all the tick-borne tests. They had run them all, and it all come back negative. And he was aware of that, and we made him aware of it again. And he said, those are just tests. They don't always tell the whole story. So we're going to treat you with doxycycline. And they did doxycycline IV, and he was a new person in 24 hours. Yet it took him nearly a year to totally recover. He had to stay on doxycycline for like, I want to say 90 days, something like that. But it got serious, and if it hadn't been finally treated, it would have killed him. Lyme's disease, my dad's brother's wife, my aunt, has Lyme's disease and was misdiagnosed and basically ignored and told her it wasn't such a thing in Oklahoma. And she found 2 Lyme disease specialists, one in New York and one in Texas. She went to the guy in Texas, and he just really wasn't happy with the way he treated it. Went to New York, and she's a new person now. He's had her on antibiotics off and on for 3 years. And very strong tetracycline antibiotics is what you want. And she's a completely new person now because of it. So these are not to be taken lightly. There are telltale signs, but not everybody gets those telltale signs. She diagnosed herself and went to a doctor finally that would treat her for it. And of course you can study a lot of that yourself. My wife had Rocky Mountain spotted fever. We diagnosed that before we ever went to the emergency room with it. And no telltale signs, but the time frame was perfect from when the tick bit her to when she started showing symptoms. We mentioned it to the emergency room guy. He checked everything and said, yeah, you're probably right. So gave her a shot of Rocephin, an antibiotic doxycycline, she went home and she was fine. Got it before it ever got into the joints. These rickettsials love to get into the joints. And like in my aunt's case, it had gone so long when it got in the joints, they had to off and on antibiotics for 3 years to kill that bacteria out. It will give you lifelong flu symptoms, where you run in part fever one day, part fever another day. One day you feel fine, one day you ache all over, you can't hardly walk, you have arthritic symptoms. It's awful. These things are just awful. And it has to lessen your longevity as far as livelihood, because you're in pain a lot. So these are some serious diseases that are tick-borne, and we live in the middle of tick country. And ticks have adapted quite well. When I was a kid, there was no ticks in West Oklahoma. Now I go out there and catch more ticks than I do here. So that finishes up that chapter. Takes us over to the crustacean chapter. And this chapter is dealing with your crabs and crayfish, and Japanese crab fits this one. It's the biggest. It's huge. Some of the main things we want to look at here is they'll have 2 pair of antennae. All of them fitting in this category have 2 pair of antennae. Most of them will have gills, just good old gills, because they're aquatic. And by far the largest class of crustaceans is class Malacostraca. You'll need to know that class when we do our lab, probably next week, when we dissect the fish, crayfish, and grasshopper. And we may just do the crayfish and grasshopper and save the fish till the next week, because we'll do perch and sharks. So that'll give us time to get to the shark chapter. So you'll need to know class Malacostraca and phylum Crustacea. And I think the lab asked that question. Notice the interior end of the non-segmented rostrum. That's kind of a nose piece. It's like a helmet that protects the interior portion of their mouth. And then a posterior end, non-segmented telson that have an abdominal segment area called uropods. Now the telson and uropods combined is like a rudder. It guides them the direction they're going. And I do have a test question about their rudder, their udder, rudder, I think it is. Uropods and telson is what it's in reference to. The carapace is the hard shell that covers the gills. They'll shed this from time to time. They'll still have a very thin layer of a shell there, but the hardness shell is the carapace. When we do the crayfish, you'll have to identify a lot of exterior parts. And most of those exterior parts, well, page 426 is a good reference page for you when we get to that lab. In fact, I think the lab's based off that page. Respiratory system is gills, like we said earlier. If you flip on over to circulatory system, it's an open system. Our system is a closed system. Their system is an open system. And because it's an open system, they have to move to get their blood to move. Closed system, it's all within vessels with a pumping organ. Now, some of these pictures, in top of 429, it'll show on this crayfish there's a heart. It's not a true heart as ours would be as far as the pumping organ. They need to move stuff around, and to do so, they need to move. Hemolymph is what they have. It's not considered true blood. It'd be like our lymph system, really. Excretory system, they'll have antennal glands, they'll have maxillary glands, or they'll have what's called green glands. One of those 3 will be making up their excretory system. On 430, the balance organ for most arthropods in general, it's listed here under the crustaceans, but the balance organ is a statocyst, and that is a test question, should actually be on your study guide as well. The balance organ is a statocyst, and it's on page 430. And what makes that, or helps that statocyst to work, are these little rocks in their head called statoliths. Now we have rocks in our head, but ours are called otoliths. Theirs is called statoliths. But rocks move in a fluid, bend some nerve endings, which gives them a sense of balance, goes to their little teeny brain that they might have. In some cases, it's not even a brain, it's just a ganglia that gives them a sense of balance. But the statocyst organ is the organ of balance. And then on 431, they go back to the molting process, which is ecdysis. And ecdysis uses the molting hormone ecdysone. We see on the next page that you have X organs on these crustaceans. The X organs produce a molt inhibiting hormone. When we don't need to molt, we're holding what we have, and the Y organ produces the molting hormone ecdysone when we're ready to molt. And there are some crustaceans, the only time they can reproduce because their shell is so large and hard is during molting process. And some crabs actually fit this. And they always know when the molting's starting because that's when the male crabs start hanging around, helping them slip right on out of that shell. See what I'm saying? Reproduction time. Feeding habits. How many of y'all like to eat shrimp? Shrimp's it's especially, you like it boiled or fried? You just like shrimp. Well, shrimp's one of the most disgusting things you could probably eat, next to sushi. At least you cook the shrimp, right? But shrimp are filter feeders, suspension feeders. They eat what nothing else will. Probably eat the crap of everything else. Kind of clean up, bottom dweller kind of thing. They're still pretty tasty. Is that going to deter you eating them? And just dip it in a little more sauce. That ought to take care of it, hadn't it? Suspension feeders. Some are predators, and most of those would be your crabs and crayfish. They're pretty good predators. Why else would they have the big pinchers going on, right? They can capture things with. And then the scavengers. So the scavengers, that's going to be your shrimp. Your suspension feeders will be your shrimp as well. All right. Any questions? Look on 437, the last two things I'm going to point out here. And they're just saying this again. We've already hit this one. Class Malacostrata. There it is right there. That's your crayfish. When we dissect the crayfish, at the top of that paper you're going to fill out, it's going to ask you what class this little crustacean's from. Class Malacostrata. And then you turn over to 440, and it'll ask you what order this is coming out of. Kingdom, phylum, class, order, family, genus, species. Remember that? Order Decapoda. Order Decapoda. And in this order is where you find the largest of all arthropods. The Japanese spider crabs, they fit in here. Lobsters, crayfish, they all fit in here in this particular order. And there's about 18,000 species of decapods. Extremely diverse, very important ecologically and economically. Of course, economically, that's a huge food source for a lot of animals besides ourselves. I mean, red lobster makes a living on this, right? And even hermit crabs fit in this as well. So that finishes up that chapter, and it gets us ready for the hexapods, which hexa means 6 legs. That would be our grasshoppers, our insects. That's where we'll start up. What's today? Thursday. We'll start there next Tuesday and see how far we get. So with that said, if we'll migrate on up the lab, we'll start dissecting the worms today. You will need goggles and gloves.